Hello friends, welcome to my channel. I'm very happy to see you all through this video. As I told you, polymers are used in different sectors, for example, plastic industries, elastomer industries, paint and fiber industries, and varnish industries. And also we have discussed about what are the polymers and how they are classified, what are synthetic polymers, what are the natural polymers, what are semi-synthetic polymers. All the concept I have discussed in the previous video, and also I have given complete details about the polymer classifications based on the polymerization reaction in the previous class. Today we are going to learn about the classification of polymers based on the molecular force involving the reactions. As I told you, polymers are used in different sectors, okay, which the usage of the polymers is mainly depends on their unique properties. First, the polymers usage is mainly depends on their unique properties, okay. The first property is mechanical properties. When you look at the mechanical properties, you must know some other properties like tensile strength, and elasticity properties, and then toughness. The usage of the polymers in the industries is mainly depends on their unique properties. For example, mechanical properties. When you look at the mechanical properties, you must know tensile strength and elasticity and toughness, okay. The mechanical properties of any kind of the polymer is mainly depends on the molecular force, okay. The mechanical property is depends on intermolecular force involving in the polymers, okay. Depends on intermolecular force. For example, van der Waals force and hydrogen bonding present in the polymers, okay. In this class we are seeing classification of polymers based on the molecular force. When you're trying to use any polymers, the polymers should have some unique properties, like mechanical properties. Under this category we will discuss about the tensile strength, elasticity, and toughness. The mechanical properties mainly depends on the intermolecular force involving the polymers. For example, van der Waals force and hydrogen bonding present in the polymers. Under this category we will classify into 4 categories. First one is elastomers. When you classify the polymers based on the molecular force involving the reactions, we can able to classify them into 4 categories. First one is elastomers and fibers and thermoplastic polymers, and then thermosetting polymers. We can classify the polymers based on the molecular force involving the polymers. Under this category we can classify into 4 types. First one is elastomers, fibers, thermoplastic polymers, and then thermosetting polymers. Okay, now we are going to see what are the examples for the elastomers, what are the examples for the fibers, what are the examples for thermoplastic polymers, and what are the examples and what is the thermosetting polymers. Okay, now we are going to see elastomers. First we are going to see elastomers. Elastomers are rubbers. These are like rubbers. These are rubbers, like it has some elastic properties, okay. These are polymers. It has elastic properties, and the physical nature is solid, okay. The polymer chain present in these elastomers are held together by intermolecular force. The polymer chain present in this polymer held together by intermolecular force, okay. Elastomers are these are like rubbers. It has some elastic property. It must have some elastic property. The physical nature is solid. The polymer chain present in these elastomers held together by intermolecular force, okay. A few cross-linked polymer chain will be introduced in this elastomer material, which help them to retract after the force was released, okay. In our daily life we are using cloths which has some elastic in nature, okay. after you releasing the force, you can take some elastic properties of containing some cloths, and then take it, we can enlarge them as long as you want. Okay, and then when you release the force, it comes into the original nature. Okay, original nature. What are the examples for these elastomers? Buna, yes. Example is Buna, yes. Buna, N, and then neoprene. Neoprene are the examples for the elastomers. Okay, now we will see some structure. Okay, CH2 Cl double bond CH CH2. This is the structure of neoprene. When you are preparing some national exams, okay, for example NEET or JEE Advanced, for any exams, you must know some examples for the elastomers. Okay, these elastomers are the rubbers. It has some elastic properties. The physical nature is solids. The polymer chain present in these types of elastomers, the polymers chains are held together by intermolecular force. Okay, what are the examples for the elastomers? BNOS, BNON, and neoprene. This is the neoprene structure. Okay, next we are going to see fibers. Fibers are thread forming solids. Next we are going to see fibers. These are the thread forming solids. Fibers, these are thread forming solids. It has high tensile strength. It has high tensile strength and high modulus. High modulus. These characteristics properties can be attributed to strong intermolecular force, like hydrogen bonding. Okay, strong intermolecular force like hydrogen bonding. Okay, fibers are thread forming solids. It has the high tensile strength, high modulus. These characteristic properties can be attributed to the strong intermolecular force, like hydrogen bonding. What are the examples for the fibers? Here is polyamides like nylon 6,6, and then polyester are the example for terylene are the example for the fibers. Now we are going to see some structures. What the example for the polyamides or nylon 6,6. This is a structure of nylon 6,6. This is the example for nylon 6,6. The strong force also lead close packing of the chain. The strong intermolecular force present in these polymers can lead close packing of the chain. Okay, we have seen fibers and elastomers. Next we are going to see thermoplastic polymers. What are the examples for thermoplastic polymers and their properties? We are going to learn now. Thermoplastic polymers. These are linear and branched long chain molecules. Okay, these are the linear or slightly branched long chain molecule. Okay, thermoplastic polymers contain linear or slightly branched long chain molecule on heating. For example, you can take PVC pipes. In our daily life we are using PVC pipes for different usage in our home. You can take a PVC pipe and then you can heat them under some temperature. Okay, you can see when you heat the material, the PVC pipe will be the properties of the PVC pipe will be softening. On cooling you can get the PVC pipe with the hard properties. Okay, for example, the intermolecular force present in this material between the elastomers and fibers. Intermolecular force attributed between intermolecular force of attraction between elastomers and fibers. Okay, for example, polythene and the polystyrene are the example for the thermoplastic polymers. Thermoplastic polymers contain linear, slightly branched chain molecule. It has the intramolecular force of attraction between the elastomers and fibers. Polystyrene and polyethylene are the example for these kind of polymers. For example, PVC. PVC are the example for the thermoplastic polymers. Okay, next we are going to see thermosetting polymers. Thermosetting polymers. These polymers are linked heavily with branched molecule. Okay, thermosetting polymers. Thermosetting polymers are linked with heavily branched molecule. Thermosetting polymer. These polymers are linked with heavily branched molecule. These polymers are linked. These polymers are linked with heavy branched molecule. Heavily branched molecule. Okay. In the case of thermoplastic polymers, we can reuse them and you can change any shape on heating and cooling. But in the case of thermosetting polymers, we cannot reuse. These polymers cannot be reused. But thermoplastic polymers, we can reuse them by heating or cooling. Okay. But these polymers cannot be reused. Thermosetting polymers cannot be reused. Thermosetting polymers contain heavily branched molecules. But in the case of thermoplastic polymers, contain linear or branched long chain molecules. Okay. These are some of the common examples for thermosetting polymers. Some of the common examples are urea formaldehyde resin, urea formaldehyde resin, and then bakelite are the example for thermosetting polymers. What are the structure for the bakelite? Now we are going to see the example for thermosetting polymers. Bakelite are the example. Bakelite and urea formaldehyde are the example for thermosetting polymers. What is the structure of this polymer? OH, CH2, OH. Okay, this is the structure of the bakelite. Okay, bakelite. In this class, you have learned classification of polymers based on the molecular force involving in the polymers. Under this category, we can classify into 4 types. First one is elastomers, fibers, and thermoplastic polymers, thermosetting polymers. Under this category, I have explained each topics. I hope you have learned and you understand the concept behind this classification. Thank you so much for watching these videos, friends.